Hi guys, welcome to Essentials of Math. This is grade 9 lesson on solving linear equations, and I'm taking you right back to when you started school. And when you think of linear equations, think balance scale. What happens on one side, if you want to keep your balance scale balanced, what goes on one side has to equal what's on the other side. So I've taken that scale model and I put it into a paper model. So you might see that on some of your assignments. And what you're going to see is that one side always equals the other side, and you keep that center fulcrum right in the middle. And you can always check your answer to see if you've solved for it. Now, variables are those unknowns. It can be an X, it can be a Y, it can be an N, it can be any letter of the alphabet. But you have been doing these variables right since the day you walked into school, because your teacher would have put these little happy face signs on the board to start you off in grade 1 math. And these are variables, this star and this happy face. And yet looking at it now, you will know exactly what the answer is without even thinking twice. Because this happy face plus 7 is going to equal 9. So absolutely, you know that this happy face is actually 2. And the opposite of addition, this draws, solving linear equation draws on all the facts and information you've learned from before. So the opposite of addition is subtraction. So if we take this over here and we subtract our 7, we know that 9 take away 7 equals your 2, and that's what comes over to replace your happy face. Now if you take a star and a star subtract 2 equals 8, we know the opposite of subtraction is addition. So you are going to add your 2 over here, and your 8 plus your 2 equals your 10. So you know that your star is going to be okay. So then we carry on. Not only do you want to be able to solve linear equations mathematically with pencil and paper, but you want to be able to show a model or represent that linear equation with a model. So I want you to draw your attention to this poster on LG tiles. It will always be up in the classroom. You'll always have it as a reminder, just to remind you of what's positive, what's negative. So when you're looking at these very large tiles, you know that it is square rooting. It's square rooting the unknown variable of x. When you're taking a look at these small tiles, you will notice there's red and there's white. Well, the red is always your positive, your negative is always your white. When you're looking at these longer algebra tiles, you will also have, but they're green and white. And one again is positive and one is negative. So if you remember, always your negatives are white, your colors are always your positive numbers. So take a look at what I put out here. This, if you had to represent, you have 2, and if you want to look up here again, remember it can be x, it can be y, it can be s, it can be any unknown variable, any letter representing it. So you have 2, you can represent it by a number of 2x. Then, why did I put a negative here and not a plus sign? Well, these are white. White represent negative, and we have 1, 2, 3, 4, 5, 6 of these. So you have a negative 6. And now, if you want to solve for that 2x equals, you have to then do the reverse. We are actually taking LG tiles and coming up with a numerical equation. So this one, we are building numbers from what we are given visually as a model. So 2x, negative 6, so we put the subtraction sign in, equals, and now these 6 are red, so we know it's a positive 6 back again. So your equation is 2x minus 6 equals 6. Now I want you to look at this equation. This is now modeling a mathematical equation and creating a model from it. So 5x, you have your choice out of what you would utilize. You're not going to use these. These are your x squared. These are your symbols for your x. Now you have to decide, are you going to use the white side or the green side? It's a positive 5x, so we're going to use green. And you're going to take actually 5 of these green and create your model of that. So you've got your 1, 2, 3, 4, 5, and now you are adding 1. And again, you have to decide, am I using the white or the red? You're using the red because it's positive. We'll borrow the equal sign from here, and you have negative 14. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now you've taken a mathematical representation of a linear equation and created an algebraic model. Now we're going to move one step further, and I'm going to get an equation here, and we're going to actually solve for this equation so that you can see that process of where we have just visualized and come up with numbers to where we've got an equation and we are creating that model. Now we're going to actually solve that linear equation. So if you have 3x, you're back to creating 1, 2, 3. But again, it's negative 5. So you're using the white side, and you have to pull out 5 of these algae tiles. Those represent your negatives, equals, and now we have 4. Now that's not solving for the equation. That's merely building what you were given as a number line. How do we solve this? Well, the opposite, and this is where you're going to do recall from what you've learned from previous years in math. The opposite of negative is positive. So if we do that, and again I'm going to draw you back to that balance scale, because what we do on one side, you have to do on the opposite side. So now you have a negative 5, we are going to add positive 5. And I call this zeroing out. You want to zero out so that you have x alone on one side of that balance scale. So these 5 positives are going to cancel out these 5 negatives. But again, what you do to one side, you have to do to the other side. And our equal sign is always your center fulcrum. So now you're going to add, we added 5 to that side, we have to add 5 to this side. Now if you take a look at this gets zeroed out. So you are going to have, and I'm going to borrow this equal sign, right now you have 3x and you have 4 plus the 5 is your 9. Now that still hasn't solved the final equation because we have 3 of these. And I'm just going to create 3 rows because it's easier visually to see. Now how do we solve for just one of these x's? Well, we're going to take these and put these in 3 rows. And you will actually visually see that if I drew an imaginary line across, that you would see that just 1 is going to equal positive 3. So your final solution to that linear equation is x equals positive 3. All right, hello students. We're working on single-step linear equations this session, and it's taking only a specific look at single step. That means there's only one math operation involved in coming up with your answer. Now this goes back to the session on, we looked at a balance scale, and you have to take a look, and what you do on the left side, you do on the right side. The middle center of the balance is our equal sign, so that's just a reminder to keep that visual in your head so that it helps you through this process. Now with single step operations, you are either multiplying or dividing. And you know by now that, and I put it on the board here as a reminder, the opposite of multiplying is dividing, the opposite of dividing is multiplying. So we're going to take a look at 2 questions specifically that have to do with whole numbers. So no fractions, no decimals, and we'll work it through. And we also talked about modeling and using algebra tiles to assist you. You could also use a number line as well, and we will show you how that works. Now 2x equals 12. This tells you to multiply. The opposite of multiplying will be dividing. So the number that is with that variable is the number you divide by. So 2x is divided by 2, then you divide 12 by 2. We talk about zeroing this out. So you try and always zero out using the numbers you're given. X is left, and 12, this really means 12 divided by 2, and 12 divided by 2 is 6. So you visually see there what we left off with x equaling 6 on this particular number equation, and now I'm going to show you, we talked about modeling, not just solving algebraically with pencil paper, but to show a model version of that same equation. So I'm going to try and show you that right now. If we look at algebra tiles, our original question was 2x equals 12. Well, over here, that long algebra tile represents x. So we have two of them. So I would visually draw, if I had to represent this by a model, I would visually draw this, and I'm filling it in just roughly because there are positive 2x. It's a positive 2x. And then that equals your 12. Well, those are single numbers, single units representative of those little cubes. Oops, and I want to do this so that you actually see the appropriate model. So we're going to do 12 of these. So bear with me the time here. We'll just quickly make and of course they're shaded in because they are positive as well. And so if you had to just represent this linear equation by using a model, you could definitely use algebra tiles. Now, how do we get this answer out of this visual? Here was our original equation. That's now a visual model by using algebra tiles. You would line them up so that they would actually could be fit together. So I could have probably done this a little bit easier, but I split that in two, I split this in two, and if you take a look and join this one set, you know that 1x is going to equal your 6 tiles. Now we could also represent this on our number line. 2x equals 12. Well, we're starting at 0, so I will draw a line here, and I'm just did a rough number line up to the number 12, so we stop at that number. And now on the bottom side, we're going to represent 2x. Well, we know that 1x is going to be to there, and the other x is going to be to there. So you have your 2x, and this is your 12. So that if you take a look visually, you will know that 1x in particular represents 6. So there's your pencil paper method of answering a single step linear equation, and these are your two different model representations of doing the same. All right, I'm going to erase this, and we're going to take a look at 5y equaling 25 and how to solve that. So I'm going to leave that there, and we'll move over. If you take a look, again, the opposite of multiplying is dividing. You're going to take the number that is with that variable. Y is your variable, 5 is your number, so we are dividing by 5. What we do to one side, you do to the opposite side. This zeroes that 5 out. You're left with y on the left-hand side. This really means 25 divided by 5. And your answer is 5. If we had to do that by LG tiles or algebra tiles and show a picture model of that representation, we go back to the original diagram, and now we have 5 y's. And again, they're positive, so we have to shade them in, and you are going to go with 5 this time. And we will just quickly, roughly shade them in so that you can see